Hello, everybody. Usually when I give this talk in front of general audiences, there's a question I ask, so I'll go ahead and try it here. Are there any science fiction fans here? I guess I'm in the right place. Good. Thank you. My name is Jeff Hubbs. I'm a consultant working in the fields of energy, sustainability, and information technology. I'm a recent graduate of the Public Policy Master's Program at Georgia Tech, just up the road. And when I talk to friends and relatives about what it is I was doing in grad school, they go, well, just what is public policy about? But a friend of mine had a good answer for that. It's basically trying to answer the question, what do we do? What do we do? How do we protect ourselves? How do we protect each other? What laws do we need? What is it that's important to us? What are our values? How do we regulate the things we create? And how do we allocate our resources? Now, all across the world, cultures have a baked-in relationship with the resources under their control. In our modern Western civilization, we easily recognize what some of these resources are. We've got energy, raw materials, food sources, fresh water, manufactured products, and even information. Now, much of our lives revolve around obtaining and consuming resources, and even producing or providing resources for others. We're accustomed to certain allocations of resources, and within our lifetimes, we don't perceive those allocations as having changed very much. But on longer time scales, beyond the span of our own lifetimes, those allocations have changed greatly. Looking just at world energy consumption over time, we see that sometime in the mid-19th century, what we call the Industrial Revolution, our civilization began consuming energy at an accelerating rate. But if we look at even longer time scales, we find that human beings lived as low-density foragers or farmers in communities of no more than a few dozen for about 99% of human history. So a human labor-based society like that, pre-industrial, can only generate about 1/20th of a horsepower, about 37 watts per person. And naturally that can't be continuous. Now, if we take that previous graph and divide it by world population at the same instance, we see a rise over the same period, especially in the decades after World War II. So if you think the world looks differently today than it did when the character of Sherlock Holmes was being written, you can see why it's different right here in this graph. A massive increase of per capita energy consumption, most of it powered by burning fossil fuels. Now these figures paper over the fact that per capita energy use is highly variable around the world. We can see here, the US is among the most energy intensive countries per capita. This end of the graph over here is populated by the cold countries and the ones that extract oil, which is itself is a highly energy intensive activity. The US looks to be about 4 times the world average, while the other end of the chart lie what we can recognize as the most impoverished places on Earth. Looking back at this chart again, we can look back at the past and we can see what our historical consumption has been like. But what if we could turn around and see what energy and other resource consumption would be like in the future? Will this rise continue indefinitely, or will it follow some other trajectory? Every year, the US Department of Energy's Energy Information Agency tries to do just that, with that center line being roughly the present. They try to do that out to a roughly 25-year time horizon. Now, to prepare each year's annual energy outlook report that they publish, they use what's called the National Energy Modeling System. It's a very complicated arrangement of software and data that computes energy consumption and costs. One of the components of that software suite is a macroeconomic model of the United States. Now, I've set up an instance of that software for a research lab at Georgia Tech, and they're one of my consulting clients right now while I'm updating it to the next year's version. Now, the research assistants at Georgia Tech run alternate scenarios to what the EIA's reference case is to see what the model says will change about the future as a result of the changed assumptions, different policies like cap and trade, or will people be more or less concerned about the efficiency of the appliances they buy. But there are no assurances built into the EIA's predictions. It's not supposed to be a crystal ball into the future. It's clear just by eyeballing this chart, there's nothing predicted out to 2040 that's as pervasively disruptive as the Great Recession of 2008. Can you see it there? immediately to the left of the black line, that downward notch is how serious the 2008 recession was. It affected energy consumption worldwide. Now, the kind of resource consumption that also grew up after World War II, which is off the left-hand side of this graph, or the grand expansion of the economy after World War II, goes to show that the past is crunchy. Things happen, weird stuff happens. There'll be a series of events that happens in a short time frame, and the world comes out a little bit differently than how it went in. It stands to reason that the future will be crunchy too, if only because we observe the past as having been so. Now, software models like NEMS aren't anywhere near sophisticated enough to tell us when and what the upheavals will be. So where does our society turn when it wants to contemplate the future? Well, the late film critic Gene Siskel used to refer to his job as covering the national dream beat, implication being that our movies, our TV shows, are one way in which our society dreams. Our science fiction, then, can be thought of a way for us to dream about the future, to contemplate what the future will hold. It turns out, the futures envisioned by some of our science fiction movies and TV series contemplate profound resource abundance and profound resource poverty. We're going to talk first about resource abundance and the creative thought that went into it. Gene Roddenberry was an established Hollywood screenwriter, initially known for his work on the dramatic series The Lieutenant, which starred Gary Lockwood. He played a U.S. Marine officer. Now, Roddenberry got frustrated with the network that aired The Lieutenant, NBC. NBC refused to air and even refused to pay the production company for an episode Roddenberry had written that dealt with racism. After going through that experience, he started thinking about having another storytelling venue in which he could deal with issues that were that heavy in a more fantastical and therefore less threatening setting. And so he envisioned a spacefaring ship and its crew set roughly 300 years in the future and named his show Star Trek. What Roddenberry could not have foreseen was that his wagon train to the stars, his Horatio Hornblower in space, would spawn 6 TV series and 12 feature films over 47 years, becoming the most extensive science fiction franchise in American popular culture. Although the ships and the characters would change, the story universe remains essentially the same. For the protagonists of Star Trek to seek out new life and new civilizations, the action required them to travel quickly. To avoid being too much at odds with real physics, Roddenberry posited that in order for the Enterprise to cover the distances between star systems in a practical amount of time, superluminal travel had been developed. In other words, travel faster than light. Now, superluminal travel is not something that's permitted within our contemporary understanding of physics, but it's a common story conceived throughout science fiction. Without it, crews would cycle through many generations before reaching even the closest stars. Now, as realized by Roddenberry and his writers, superluminal travel requires a lot of energy, so much energy, that requires a matter-antimatter reaction to produce it. Now, that's not make-believe. It was a process that was known to physicists in the 1960s, and is even described by Albert Einstein's famous E=mc² equation. Now, where the idea becomes fantastical is that in the real universe, there's almost no antimatter left. Being able to amass any macroscopic amount of antimatter in the real world is to us unthinkable. Although if you could, you'd have to be exceptionally careful with it. If by magic you create an antimatter nickel coin, there's nothing special about antimatter. It has the same chemical and physical properties as matter. And combine it with a matter coin, such that the mass of both coins would be converted completely into energy, you could plug the numbers of the mass of that coin, the speed of light, into Einstein's equation, and see that the amount of energy released would be stupendous, on the order of that released by a single nuclear peacekeeper missile warhead, which has about 25 times the yield of the little boy weapon that was detonated over Hiroshima in 1945. Yet through some contemporarily unfathomable technology, Star Trek's vessels perform this reaction in a controlled way, using the energy to warp space-time in the region around the ship, such that the ship could reach destinations thousands of light years away in just a few days as experienced by the ship's occupants. In the Star Trek universe, the Enterprise is far from unique or novel. It's said to be a Constitution-class starship, and which implies multiple copies in multiple generations, and is the flagship of Starfleet, engaged in exploration of necessary humanitarian and military functions on behalf of a united federation of planets. Now, the Federation planets and the space they inhabit cover roughly a quarter of the galaxy and are home to many humanoid species. External to the Federation are various other unaffiliated and antagonistic civilizations, many of whom are also warp capable. Roddenberry's core organizing principle was optimism, that the differences, conflicting motivations, and prejudices of Earth's and other planets' inhabitants would eventually be overcome in time, albeit perhaps messily and bloodily. In fact, in a recent installment of Neil deGrasse Tyson's reimagined Cosmos series, he alludes to the idea of a kind of a forward-looking weak anthropic principle, by which he meant that if there is humanity a few hundred years from now or a few thousand years from now, it will only because we overcame these problems of sustainability, conflict, prejudice, hatred, poverty, ignorance. In Star Trek universe, allusions are made to a World War III on 21st century Earth, and one episode reveals a flirtation with eugenics that spawned a tyrannical Ubermensch who ruled a quarter of the planet until he was deposed. Furthermore, technological innovation on Earth despite the setbacks, and on other planets despite theirs, has marched on relentlessly to make interstellar travel look like our cruise ship travel, and to make the practice of medicine look like the miracles of Jesus. But the characteristic of the Star Trek universe that we're especially concerned with here is the widespread ability to marshal incredible amounts of energy, to the extent that the economy of the Federation civilization has collapsed, by which I mean the need for an economy was dispensed with. During the course of the series, the various television series, offhanded references to an antiquated system of cash exchange occur, and colorful, greed-motivated characters like the Scavengers of Triskelion, Triple Peddler Cyrano Jones, hapless megalomaniac Harry Mudd, and the Ferengi species for which finance and commerce aren't like a religion, they are religion, are all regarded by our protagonists as quaintly petty troublemakers. At times, Star Trek characters are explicit about their lack of economy. After sticking a marine biologist with a check after dinner in 1980 San Francisco in Star Trek IV: The Voyage Home, she snaps at an empty-pocketed James Kirk, "Don't tell me they use money in the 23rd century," and Kirk lamely responds, "Well, we don't." In the 1996 film Star Trek First Contact, 24th century Enterprise Captain Jean-Luc Picard explains it to a woman from the 21st century who asks him how much it costs to build the Enterprise. He says, "The economics of the future is somewhat different. You see, money doesn't exist in the 24th century. The acquisition of wealth is no longer the driving force in our lives. We work to better ourselves and the rest of humanity." Our protagonists appear to have evolved past material one, for the amounts of resources they control would have obsoleted the novelty of and the status associated with the acquisition and display of material possessions. On reflection, perhaps Starfleet's size is more constrained by the availability of officers like a Kirk or a Picard than by the sheer number of ships they can build. Now, why would Gene Roddenberry have been so optimistic? As a former military man, Roddenberry knew that world wars can be won with the involved dictatorships fallen and the democracies victorious. When the first draft of the first Star Trek pilot, The Cage, was completed in September 1964, the United States and the Soviet Union were well into their manned spaceflight programs. The Mercury program had successfully flown 7 astronauts on suborbital and orbital missions, and the Soviets had flown the first woman in space, Valentina Tereshkova. Electrical power generation by nuclear reactor was in a nascent stage in both countries. About a decade earlier, then chairman of the U.S. Atomic Energy Commission, Lewis Strauss, declared in a speech that, quote, "Our children will enjoy in their homes electrical energy too cheap to meet them," unquote. By the time the first episode aired, the U.S. had completed the first soft lunar landing by an unmanned probe, and fully electronic digital desktop calculators were available on the market. But with other scientific and technical advances of the day and the dawning of the civil rights movement meant to address socioeconomic inequities left over from the Reconstruction era, a sense of optimism would have been hard to not develop. Why shouldn't these developments proceed naturally to a matter-antimatter powered starship fleet piloted by a mixed race, gender, and species crew with no need for money 300 years hence? Subsequent Star Trek series ran continuously from 1987 to 2005, and the core concept of resource-abundant civilizations remained consistent. Here's another abundant civilization, a little bit closer to our present day. The action of the 1968 film 2001: A Space Odyssey takes place against a backdrop of resource abundance set a mere 40 years into the future. Although the story revolves around the fantastical notion of starkly inhuman extraterrestrial intelligence, the imagined human experience is an extrapolation of industrial, scientific, technological, and commercial progress viewed from the 1960s perspective. In the second of the film's 4 acts, the audience is given a glimpse into life in the year 1999. A sleek-winged spacecraft with Pan American Airlines livery is depicted docking with a large rotating space station in Earth orbit. We see that one of the space station's 2 rings is still under construction. It's a work in progress. As the action transfers to the station's interior, which resembles a clean, minimalist, stylish, and functional airport, unlike the drab, cluttered, and haphazard interiors of real space stations we would see only a few years later. We see signs for the Howard Johnson's hotel chain and the Bell Systems, forerunner of AT&T, the latter of which is shown prominently as a character places a video phone call to wish his daughter a happy birthday, all for the cost of $1.70. The same character takes a transport ship from the station to a permanent base on the moon, where he gives a briefing to a group of men and women in what we recognize as business attire. This setting, with its flags mounted on poles and the typical accoutrements of formal meetings such as water pitchers and an official photographer, would be fully familiar to 1960s audiences, with the only real tip-offs that this is taking place 40 years in the future being the full-wall lighting, the oddly cut business suits, and the topical discussion. The film's 3rd act shows an interplanetary craft, the Discovery, longer than a football field, with some of her crews held in a state of suspended animation and accompanied by a wholly intelligent computer, the HAL 9000, bound for Jupiter. In the crew compartment is a centrifuge. Here, astronaut Frank Poole is taking a job. The Discovery contains 3 pods suitable for the crew to perform tasks outside the ship. The shorter time horizon, less distant technology, and the vastly reduced theater of operations all make 2001 a more believable and imminent resource-rich environment. Bear in mind that when this movie came out, in the United States there had been commercial air travel already for 40 years. The first commercially available IBM computer had come out 15 years earlier, and manned spaceflight was already 7 years along. Now, in a resource-abundant story universe, the audience is meant to react with awe and wonder. We Westerners tend to interpret the degree to which an individual organization is able to consume or convert energy as a measure of its prestige or potency. But causing awe and wonder does not constitute drama, and this poses a challenge for writing stories that are based around resource-abundant civilizations. Now, author and Star Trek writer David Gerrold characterized a successful dramatic presentation as being a broad-based format about an interesting individual or group of individuals whose responsibilities force them into unusual situations and confrontations requiring decisive and positive action on the part of the protagonist and his cohorts. The dramatic potential of a resource-rich scenario in and of itself is weak. For people who are simply free to act out their profligacy, like Richie Rich here, simply just aren't very interesting. But if abundance facilitates the other elements of drama that Gerald described, you can construct a successful drama out of it. So dramatic conflicts in Star Trek tend to center around issues of individuals' power and control, honor, revenge, prejudice, racial hatred, freedom, sacrifice, acceptance, friendship, or various ethical or moral quandaries. The limitations they face, therefore, tend to be things they can't simply power out of. We're told that the Enterprise can outrun most anything and can obliterate a planet's entire surface. But to make good stories, simply opening fire or warping away can never be allowed to be the extent of a problem solution, nor the best obvious solution, even if the protagonist takes some other course of action. Now in 2001, being able to take a shirt-sleeve ride to the moon makes for fascinating visuals, but it's not much of a plot. On the other hand, exploring the moon, discovering an unusual magnetic field in the bottom of a crater, excavating a mysterious black rectangle that emits a powerful radio signal toward Jupiter the first time sunlight hits it, being sent to Jupiter without knowing that the mission's actual intent is to investigate the signal's destination such that the computer tries to kill you because it's decided you're a threat to the mission, that's an actual plot that's rooted in deceit and the danger posed by directing an inherently truthful machine to lie. Or in Star Trek II, The Wrath of Khan, the franchise's most recognizable and beloved character sacrifices himself to save his shipmates from the detonation of a misappropriated terraforming device. A key plot point is that the self-same immensely powerful yet portable device meant to be a planet creator by some might be more valuable to others as a planet destroyer. Now, not all putative futures in American science fiction film and television have been based on a fundamental optimism. A great many dystopias exist, such as THX 1138, A Clockwork Orange, Blade Runner, and Max Headroom 20 Minutes into the Future. But certain of the dystopias have a key characteristic very much opposite that of Star Trek 2001. Their settings and the motivations that guide the characters are based on a chronic lack of resources. One film that vividly depicts this is 1973's Soylent Green. The film opens with a pastiche of still images presented Ken Burns style, starting with bucolic sepia-toned Americana scenes while a gentle gospel-tinged piano plays in the background. As the music becomes edgier and more dissonant, the pastoral imagery gives way to busy cities, giant lots full of identical cars, imposing mounds of garbage, settling finally on a long shot of a monochrome, smog-choked New York City, which we learn has a population of 40 million in 2022, with 20 million unemployed in Manhattan alone. For the most part, Soylent Green is a straightforward police procedural, like 1967's In the Heat of the Night or 1971's The French Connection. But the constant subtext girding the action in this film at all times is crushing resource poverty for the vast majority of people. The beginning of the film shows William Simonson, the wealthy director of the Soylent Corporation, being clubbed to death in his apartment by an intruder. Soylent, we learn, controls half of the world's food supply. Robert Thorne is a police detective who moonlights in homicide when he's not on riot control duty. He and his elderly roommate Saul live in a small, grimy walk-up apartment. The apartment's lit using a rack of batteries charged by a stationary bicycle fitted with a generator. Thorne's assigned to investigate the Simonson murder. Thorne and Saul's building is full of homeless people splayed out in the stairwells, and the streets are littered with immobilized cars being used for shelter. Beef is such a rare commodity that most people never see any, and the presence of a jar of strawberry jam and a woman in a silk robe in Simonson's security guard's apartment is enough to tip off Thorne that the guard is living well beyond his means. Lines form out in the streets for water and for food. Here we see bins full of Soylent Yellow and the company's new product, Soylent Green, which we are told is made from high-energy plankton. We know that Simonson's body is bagged up by a crew and carted away in a garbage truck as Thorne investigates the murder scene. Still somewhat in shock at the brutal slaying, Simonson's concubine, Cheryl, mentions to the security guard that she remembered when she was a little girl, there was a ceremony when her grandmother died, suggesting a significant shift in the cultural perception of death in as little as a single generation. Thorne's a bit of an opportunist. Apparently soap is a high luxury. He gathers up a bar along with some booze, food, and other items in a pillowcase and hitches a ride with the body disposal crew back to his apartment. Knowing that Saul was a former professor, a respected man, he says, he also brought home a large 2-volume book, an oceanographic report produced by Soylent covering the years 2015 to 2019. This excites Saul greatly. He still reveres books and has many stored in the apartment. Saul brings the book to a group of elderly men and women known as the Exchange to have them evaluate the book's contents. Later, Saul enters what we realize is a euthanasia clinic. He's led into a chamber with a bed and an observation booth off to one side. Back at their apartment, Thorne finds what he realizes is a suicide note from Saul. Thorne races through the night to the clinic to try to intervene, but by the time he arrives, Saul has taken the poison to end his own life. The walls of the suicide chamber form a giant projection screen. Images of the Earth's natural beauty vividly surround Saul in a dazzling display that visibly astonishes both men, but especially Thorne, who has never seen such scenes in his entire life. Activating an intercom between the suicide chamber and the control room where he helplessly watches the dying Saul, Thorne listens intently through an earphone as Saul speaks to him. We don't hear everything Saul says, but we can clearly hear him say, "You have to prove it." After Saul quietly passes away, Thorne sneaks outside and finds where the bodies are taken. There are a lot of them, and they're being loaded into garbage trucks, just like Simonson was. Thorne stows away atop one of the trucks and rides into what appears to be some sort of industrial facility. Once inside, the trucks are open, and the wrapped corpses are pushed out like cordwood. The facility seems mostly deserted, so Thorne presses further inside to investigate. He sees the bodies being shoveled around the factory on conveyor belts. As he explores further, Thorne realizes there's some sort of process involving the bodies as they're dropped into a pool of liquid. Finally, we see it before Thorne sees it. a conveyor belt carrying green wafers. What the exchange had told Saul and what Saul had told Thorne in the euthanasia clinic, and what Simonson knew leading him to not even bother resisting his killer, was that the oceanographic report revealed that the plankton population had actually crashed. Soylent Green is people. Through the course of the film, we're told that the New York City of 2022 is hot all the time, and that cold is something that winter used to be. Faced with the plankton crash caused by the changing climate, Soylent turned to a plentiful and readily available source of nutrients to develop the new addition to its product line. Now, this chart shows the fossil fuel inputs that go into food production in the United States. As you see from the consumption side, it's broken up into things like storage and preparation on the household end, commercial food service, retail, grocery stores, and even restaurants. The packaging material, the processing of food, both from livestock and plants into something else, and then from something else into manufactured products of the like you would buy at the grocery store. Transportation, moving all that around, and the energy has to go to the agricultural production itself. You can see it's about 7 times the food energy available. So for every BTU worth of energy we consume in our food, our civilization has put 7 times that in fossil fuels into just getting it to you. Now imagine how those energy inputs would change if food products could be transported at high densities, didn't have to be refrigerated or prepared, and for which the primary component walks into centralized processing facilities voluntarily on its own 2 feet. Looking beyond the film's central conceit of industrially sanitized and packaged cannibalism, the privation shown in Soylent Green can be discerned as not constant, but accelerating even as the status quo impoverishment level was being outwardly maintained. All the public sees is a new and improved food wafer. What's really happening is a collapse of the planet's ecosystem. Soylent Green dramatizes the human race well into a state of overshoot.